Oh, cool. Awesome. Should I do anything? Okay, so yeah, we'll go over how to draw Lewis structures today. So this is hopefully just going to be a little reminder of stuff that you've learned before. So we're going to utilize something like, let's just say, ammonia as an example here. Okay, so actually, number one, I wasn't correct. It's not summing up the valence electrons. The first step in drawing any type of correct Lewis structure is to draw the correct skeletal structure. Skeletal structure. And so what I mean by that is how everything is actually going to be attached to one another, right? So we have two different atoms here. We've got a nitrogen and then we've got hydrogen. And the question is, who's actually going to be around who, right? So hopefully you guys learned in 151 that the least electronegative element is always going to be in the center, and that is almost always the thing that is written first in the chemical formula, right? So for ammonia, NH3, we've got nitrogen right in the middle, and it's going to be surrounded by the three hydrogens, right? So we've got hydrogen, hydrogen, hydrogen. Again, this is what I would mean by a skeletal structure, right? This is kind of just the skeleton of the actual molecule that we're drawing. All right, so once that's done, number two, we want to sum the valence electrons. And hopefully, if you guys remember how to know how many valence electrons an atom has, it's essentially going to be whatever column it is in the periodic table, right? So we look in the periodic table, we'd find hydrogen in the first column. So that means it has 1 valence electrons. And then we have nitrogen. Nitrogen in column 5, it has 5 valence electrons. So for this guy, if we're summing these, we've got nitrogen. This guy has 5 valence electrons. And then we've got 3 different hydrogens. So 3 hydrogens. It's going to be 3 times the 1 valence electron. So overall, we get 8 valence electrons. Okay, so we've got skeletal structure. We've got our valence electrons. Now the third step is going to be to distribute, okay? And when we distribute these electrons into our structure, the first thing we're going to want to do is make single bonds first. So single bonds between our central atom and then what we'll call our terminal atoms out here. So if I just go 1, 2, 3. If you guys remember, the big thing with respect to Lewis structures is we're trying to obtain an octet of electrons, meaning we want 8 electrons around every atom. The only exception to that for right now is going to be hydrogen. Hydrogen only wants 2 electrons. We call that a duet. And notice an electron or a bond we represent as 2 electrons. So right now, hydrogen has 2 electrons, hydrogen has 2 electrons, hydrogen has 2 electrons. So hydrogen is good. The only problem is nitrogen, right? So if we say we have 2 electrons here, 2 electrons here, 2 electrons here, nitrogen only has 6 electrons around it. Again, though, we're distributing our valence electrons. And if we put 2, 4, 6 into the structure, we had 8 to get rid of initially, right? So what do we do with those extra 2 electrons? Well, that's when you're going to make a nice lone pair of electrons on whatever this central atom is, okay? And so if we look at nitrogen again, now we have 2, 4, 6. And with these lone pair of electrons, we have 8 electrons total. That's going to give us our nice octet around nitrogen. And we have distributed all of our valence electrons. Okay, so skeletal structure, you're going to sum the valence electrons, then you're going to distribute single bonds first, and then if you have any excess left over, you're going to put them as a lone pair on whatever the central atom is. Okay, so hopefully you guys